schedule lunch with Sam. The agent checks your calendar, finds Sam, drafts a message,
Sent to the wrong Sam.
So, what makes an AI agent different? The important part isn't that an agent can answer, it's that it can act. And once an AI system can act, vague instructions stop being harmless. Agents connect fuzzy language to strict systems. You say, clean up my inbox. An API needs exact rules. Which emails? Older than when? Archive or delete? Ask first or just do it? That gap is where agents become useful. And that gap is where they break. By the end of this video, you will have a simple 4-level system for judging how much power an agent should get before it starts touching real tools. And the whole difference becomes obvious with one simple lunch request. Chapter 1. Chatbot versus agent. Imagine you want to schedule lunch with Sam next week. You ask a chatbot, help me schedule lunch with Sam. It answers, you could ask Tuesday or Wednesday. Helpful, but it did not actually move the task forward. It gave advice. An agent would do it differently. Find available slots, draft options, and request approval. Now, imagine an agent with the same request. It searches your contacts, finds Sam, checks your calendar, finds 2 free lunch slots, drafts a message with both options, then stops and asks, should I send this? Same language model, completely different system. A chatbot gives answers. An agent moves work forward. But here is the part most people miss. The model is not the agent. The model is the brain. The agent is the system around the brain. The goal, the tools, the memory, the permissions, and the loop that connects them. The model is the brain. The agent is everything around it. But that loop, the engine that makes agents actually work, is also the thing that makes them risky. Chapter 2. The agent loop. Most people imagine an agent as one magic prompt. You type a goal, the model thinks hard, and everything works. That is not how useful agents work. They run in cycles. Goal, decide, act, observe, repeat. Back to the lunch example. Decision, I need to find Sam. Action, search contacts. Observation, there are 2 people named Sam. The loop now has new information, so the next decision changes. Now it decides again, checks recent emails for context, finds the right Sam. Decision, find free lunch slots. Action, check calendar. Observation, Tuesday 12:30 and Wednesday 13 p.m. are open with no conflicts in the calendar. Decision, draft a message. Action, write the draft. Observation, sending requires approval. The agent stops and asks. And this is where it gets interesting. A good agent is not always acting. Sometimes the right next step is to stop, to ask, to wait. The loop is not act, 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 act. The right loop looks like this. First, think about the next step. Then, act on it. Then, observe the result. Then, check the risk. And finally, continue or stop. Every cycle, this loop repeats. Agents need a finish line. Without one, they wander. The prompt must tell the loop what completion looks like. Most people say, plan my meeting. That is too vague. Better, plan my meeting, done when 2 conflict-free times exist and I have approved the message before it is sent. A goal without a finish line is an invitation for the agent to wander, and they break in predictable ways. But knowing the loop is not enough, because loops break. Chapter 3, Why agents fail. Here is the part that most agent demos skip. Agents fail in predictable ways. And often, the model is not the real problem. Failure 1, vague goals. Bad prompt. Clean up my inbox. Archive newsletters, delete spam, reply to clients. If the agent has too much permission, its guess becomes an action. Good prompt? Find 30-day-old newsletters, label them review later, and ask before archiving. Failure 2, weak tool descriptions. A tool called process data is useless. A tool called find open customer refunds makes the decision obvious. Failure 3, too many tools. Sounds strange, but 20 similar tools create noise. The agent wastes time choosing, picks the wrong one, or combines them in unexpected ways. Failure 4, unsafe permissions. This is the big one. This is the moment where a bad agent stops being annoying and starts becoming expensive. A bad summary wastes your time. A bad action can delete the wrong file, send the wrong email to a customer, or update the wrong record in your CRM. An agent that can read, write, delete, and send without review is powerful. But power without checkpoints is dangerous. Draft before send. Label before delete. Suggest before change. Ask before committing. Those small gates turn risky actions into reviewable steps. Sounds simple? It is not, because most teams skip these boundaries during demos and then wonder why production fails. But notice something. None of these failures are solved by simply swapping in a smarter model. They are design problems. Chapter 4, Tools, Memory, and Context. Here is the mistake that ruins many agent workflows. People upgrade the model when they should upgrade the environment. The agent did not need a smarter brain. It needed better context, clearer tools, or safer memory. Because an agent is only as useful as the world it can see and the actions it can safely take. Tools let the agent act. Calendar, email, file system, database. Without tools, the agent can only talk about the task. Context is what matters right now. The user's request, the current conversation, the relevant document. Memory is what the system remembers over time. Sam prefers late lunches. You avoid Friday meetings. Your team writes short emails. Memory helps consistency, but old memory can be worse than no memory. If the agent remembers Sam prefers Wednesdays, but Sam changed teams 6 months ago, that memory becomes a trap. Before, help me reply to this customer. After, use the customer's last message, their order status, and our refund policy. Draft a polite reply with one clear next step. Do not send without approval. The second version does not make the model smarter. It makes the system better informed. Context first, action second. So now you know why agents fail and what they actually need. The last question is, how much power should you give them? Chapter 5, Safe Agent Design. So how do you build an agent that is actually useful, not just impressive? The answer is not give it more access. The answer is give it the least access needed to complete the task safely. Think of it as 4 levels. Level 1, read only. Summarize, inspect, compare, change nothing. The agent can see information, but it cannot change the world. Level 2, draft only. Prepare emails, documents, code changes. Send nothing. It creates useful work without crossing the send or commit line. Level 3, execute with approval. Act, but only after a human confirms. The final checkpoint stays with a person. Level 4. Automatic. Act without asking, but only for low-risk, reversible tasks with strict rules.
Back to Sam. Level 1. Show me my free lunch slots. This is useful because nothing changes without your involvement. Level 2. Draft a message to Sam with 2 options. The agent prepares work, but it does not send anything. Level 3. Send it, but only after I approve. The power is real, but the checkpoint stays human. Level 4. Automatically archive the confirmation once Sam replies. You do not start at level 4. You earn it.
Confidence is cheap. Reliable behavior is valuable. And that is why logs matter. A good agent should be able to say, I checked the calendar, found 3 conflicts, drafted 2 options, did not send, approval required. If you cannot inspect the agent's behavior, you cannot trust it. The best agent is not the one with the most power. It is the one that uses the right amount of power at the right time. More power does not make a better agent. Better boundaries do. That is the practical rule for safe agent design. Remember that first demo? The bad approach. Broad goals, all tools, no review. The better approach? Clear goals, right tools, approval gates. It was not a model problem. It was a design problem. The real question is never, can this model answer me? It is, can this system safely move work forward? That is what separates a chatbot from an agent. The model is only the brain. The loop gives it direction. The tools give it reach. The permissions decide whether it is useful or dangerous. But there is one more problem. How does an agent actually connect to calendars, files, databases, apps, and workflows without every developer building custom wiring from scratch? That is where MCP comes in. And in the next video, we will separate MCP from function calling because they are related, but they are absolutely not the same thing. That is the next layer. How agents connect to the outside world. This is where the agent stops being isolated. Have you tried any of these tools or tricks? Let me know in the comments. And if you found this useful, hit that like button, subscribe, and turn on notifications so you never miss an episode.